Hello, dear students. Glad to meet you again in this session. Now, in this session 1.5, we are going to see the laws of chemical combination. In the same chapter, chapter number 1, in some basic concepts of chemistry, grade 11. Before getting into this session, let us recall all the concepts that we have discussed in the previous sessions. In the first session, we have discussed the importance of chemistry and nature of matter. And under the heading matter, we have seen the classifications of matter. In the second session, we have discussed about the 7 basic units of SI system, its definition and its symbol. In the third session, we have seen the measurements of matter, some physical quantities and the properties of matter. We have seen about mass, weight, volume, density, and temperature. In session 4, under the heading Uncertainty in Measurements, we have discussed about scientific notation, significant figures, precision and accuracy, and dimensional analysis. Learning outcomes. Students, at the end of this session, you will be able to list various laws of chemical combination, define various laws of chemical combination, and explain the various law of chemical combination. Students, we know that elements combine to form compounds. While they react with each other, they combine according to certain laws, and we call these as laws of chemical combination. Under this laws of chemical combination, we are going to discuss law of conservation of mass, law of definite proportion, law of multiple proportion, Gay-Lussac's law, and Avogadro's law one by one in detail. Law of conservation of mass. This law was suggested by Antoine Lavoisier, a French chemist, in 1789. Law states that matter can neither be created nor destroyed. When mercuric oxide was heated, it gives free mercury and oxygen. In our case, if the mass of mercury is 92.6 and the mass of oxygen is 7.4, then the sum of the mass of mercury and oxygen was found to be equal to the mass of mercuric oxide, that is 100 grams in our case. Let us see the law of conservation of mass with an illustration. Take hydrochloric acid in a conical flask and a test tube containing silver nitrate solution. Insert it inside a conical flask as shown in the picture and weigh the weight of the whole apparatus in a balance. Now, tilt the conical flask so that the two solutions get mixed. A white precipitate of silver chloride will be formed, showing the reaction occurred. Now weigh the weight of the whole apparatus again. There is no change in the weight before and after the reaction. From this experiment, we infer that during any physical or chemical changes, the total mass of the product remains equal to the total mass of the reactant. Law of definite proportion. This law was given by a French chemist, Joseph Proust, in 1799. And this law deals with the composition of chemical compounds. Law states that a given compound always contains exactly the same proportion of elements by weight. Proust worked with two samples of cupric carbonate. One is a natural sample and the other is a synthetic sample. He found that irrespective of the source, the percentage of copper, oxygen and carbon in this given sample cupric carbonate always contains exactly the same proportion of elements by weight. Let us see another example. If we take pure water obtained from different sources like river water, well water, rain water and so on, it always contains hydrogen and oxygen combined together in the ratio 1:8 by mass. Here we are speaking about the mass of the element, not about the number of atoms or volumes. So irrespective of the source, a given compound always contains the same element element in the same proportion by mass. Law of multiple proportion. This law was announced by John Dalton in 1803. Law states that if two elements, here what are all the two elements we have taken? One is carbon, another one is oxygen, combine with each other to form two or more compounds. Here how many compounds are formed? Two compounds. One is carbon monoxide and the other one is carbon dioxide. Then the mass of one element, that is oxygen here, that combines with a fixed mass of another element. What is the fixed mass of another element? Here is carbon, are in the ratio of small whole number. Let us see this law with illustration. Look at these two pictures. Here, 12 parts by mass of carbon combines with 16 parts by mass of oxygen to form carbon monoxide, and here 12 parts by mass of carbon combines with 16 plus 16, 32 parts by mass of oxygen to form carbon dioxide. So the ratio of masses of oxygen which combines with a fixed mass of carbon, that is 12 parts in these compound, is here 16 is to, here 16 plus 16, 32, 16 is to 32, or we can write it as 1 is to 2, which is a simple whole number. Gay-Lussac law of gaseous volume. This law was given by Gay-Lussac in 1808. Gay-Lussac performed many reactions in which gaseous species were involved. He observed that there exists a definite relationship between volume of the gaseous species involved in the reaction. Law states that when gases react with each other in a chemical reaction, they do so in volumes which bear a simple whole number ratio to one another and to the volume of the product if these are also gases provided. All gases are at the same temperature and pressure. Let us see the Gay-Lussac law of gaseous volume with an illustration. We have taken hydrogen gas. Hydrogen combines with oxygen gas to give water vapor. Both the reactants and products should be in the gaseous form. Here we have taken 100 ml of hydrogen reacts with 50 ml of oxygen to form 100 ml of water vapor, and it bears in a simple ratio of 2 is to 1 is to 2. What is the volume of hydrogen? 2. What is the volume of oxygen? 1. What is the volume of water vapor? 2. So it bears a simple ratio of 2 is to 1 is to 2. Actually, this Gay-Lussac's law of gaseous volume is the law of definite proportion by volume. We have seen law of definite proportion, but we have expressed the law of definite proportion there by mass. Here we are expressing this law by volume. So it is actually the law of definite proportion by volume. In other words, we can state that there is a simple relationship between the volume of the interacting gases. What are all the interacting gases here? Nitrogen and hydrogen. And the volume of the gaseous product. What is the gaseous product over here? Ammonia. Under the same condition of temperature and pressure, that is very important. So 50 ml of nitrogen combines with 150 ml of hydrogen to form 100 ml of ammonia gas. Thus, the simple ratio by volume of nitrogen, hydrogen and ammonia is 1 is to 3 is to 2, because 1 volume combines with the 3 volume of hydrogen gives 2 volume of ammonia. So, the ratio is 1 is to 3 is to 2. Avogadro law. This law was given by Avogadro in 1811. First, let us see his law. Avogadro proposed that equal volumes of all gases at same temperature and pressure should contain equal number of molecules. Avogadro made a distinction between atoms and molecules. He stated that the smallest particle of a substance that has an independent existence is called molecule. Avogadro argued that since the smallest particle of the gases that has an independent existence is a molecule and not an atom, hence the volume of gases should be related to number of molecules and not number of atoms. Here we could see two volumes of hydrogen combines with one volume of oxygen to form two volumes of water vapor. Equal volume of all gases under similar temperature and pressure contains equal number of molecules. Just for understanding, they have given if one volume of hydrogen contains 5 molecules of hydrogen, then one volume of oxygen also will have 5 molecules of oxygen. Students, let's recall what are all the concepts that we have discussed in this session. We have discussed the definitions of various law of chemical combinations. What are they? Law of conservation of mass, law of definite proportion, law of multiple proportion, Gay-Lussac's law of gaseous volumes, and Avogadro law. Hope this session is also very useful to you. See you soon in the next session. Have a nice day. Thank you.